Hello friends, very good morning. Myself Dr. M.H. Chennaiya. In this video, we are going to have a problem on the design of a square key. And let's see what the question we have for today's video. The question reads like this: prove that a square key is equally strong in shear and compression. This is what is to be proved. And friends, you know very well that a key fails either in shear or in compression, and you have been required to prove that these two torques are the same. So, friends, let us consider the failure of the key. The key fails either by shear or compression, and we have derived an expression for the torque transmitted by the key in shear and also that of the key in compression. You can just go through one of my previous videos and you'll be able to understand the expressions for the torque transmitted by key in shear and compression. Friends, the suppose you are having this square key, in general we can write down the torque transmitted by key in shear is given by the expression shear is given by the expression B L tau K into D by 2. Say let's call this expression as expression number 1. And where this B stands for the width of the key, L is the length of the key, tau K stands for the shear stress for the material of the key, and D by 2 is the radius of the shaft. If shaft diameter is D, then this D is the radius of the shaft. Similarly, friends, in general, the torque transmitted by the key in crushing or in compression is given by the relation h by 2 into L into sigma c into d by 2. Let us number it as the expression number 2, wherein h stands for the thickness of the key and sigma c is the compressive stress for the material of the key. D is the shaft diameter, and as usual, L stands for the length of the key. Friends, we have been asked to prove that these two expressions are the same for a square key. And what we will do, we will divide equation or expression number 1 by expression number 2, and let's see what do we get. Therefore, dividing one by the other, we get empty key in shear divided by the same empty of key in crushing or in compression, both are same. In compression is given by expression 1 by expression 2, that is B L tau K D by 2, and this is H by 2 L sigma C into D by 2. These are the expressions we have got. And friends, let's cancel this d by 2 by this d by 2. L also gets cancelled and you are left with, friends, this b goes to the numerator. It is 2b tau, 2 times b tau divided by h sigma c, h into sigma c. After simplification, you will get like this. Friends, if the key is having a square cross section like this, you will have the width of the key B equal to the thickness of the key. So B is equal to H for a square key. So with this relation, this B and H gets cancelled for a square key because the cross section will have B is equal to H is equal to same value. Therefore, friends, we are left with 2 times tau divided by sigma c. Friends, generally, For all these engineering materials generally used, the value of this compressive stress, unless otherwise specified, will be equal to double the shear stress. I can say here generally the sigma c is equal to twice tau. Is tau is tau k here? It's all the same. Tau is tau k. So with this assumption, friends, this 2 times tau will be equal to sigma c. And hence this becomes equal to sigma c by sigma c. That is equal to 1. In other words, if you simplify this, friends, you get the expression empty key in shear is equal to empty key in compression or crushing. That is to say, in other words, that a key having square section is equally strong in shear and compression. That means it will be able to transmit the same value of torque whether it is failing by shear or by crushing. Friends, I hope the presentation was interesting. Please go through the complete video without skipping any part of the video. And if you like this video, please share it with your friends without fail. Have a blessed day, and I thank you very much for watching my YouTube video.